Now that you're watching this video, that means you are a member of the channel. So you have my big thank you. So you're going to have all the questions from 1 to 30. Okay. But one special thing about this video is that last time I uploaded a video of 2023, AMT, like they emailed me, they asked me to remove the videos. Okay. So if they do that again, I'll have to remove this video as well. But if this happens, you still have the access to the video. So all you have to do is contact me, email me any way you can, and I'll make sure you have access to the video. Okay, so with everything being said, let's just start.
Let's do question 1. What is the value of this number minus this number? So as you see, the first number is smaller than this one. So the result has to be negative. These options will be out. And so what we're going to do, we're going to first minus these, the big number by the smaller one. And then whatever the result is, we'll give it a -1. So when we do this, okay, you will realize that this 2 is less than this. So the first digit number has to be 9, okay? And definitely the result has to have a negative. So this will leave us with option B, and that would be the answer. Okay, question 2. We know that PQ, this one is 10, okay? And the area is actually 60, okay? So we know that if I cut this triangle and move it all the way to here, okay, the shape we'll have, okay, will be a rectangle like this. Okay, I'm going to clean this part because we moved it. So we have moved this one over here. As you see, it will be a rectangle. And because the area is 60, this is 10. So this line over here is actually 6 from here to here. Okay, so if this is 6, what do we call it? PT, right? So PT is 6. Okay, which one of these is equal to 57 multiplied by 953? This question has been designed to waste your time. When we look at the option, you see that the differences are huge, okay? So we just need an approximation. So this is close to 1,000. So 57 multiplied by 1,000 is 57,000. Which one is close to this? Only this one, C. Now question 4, what is the difference between 2 to the 5th power and 5 to the 2nd power? This one is 2 multiplied by, say, 5 times. It's going to be 32 minus 5 times 5, which is 25. And of course, obviously, the answer will be, okay, 7E. Question 5, what is the value of the angle theta in the diagram? Okay, so you would see that here, I have to make this line over here. And this line, this is a line, okay? So it's supposed to have 180 degrees. 180 minus 110 will give us 70 over here. This is 70 degrees. Okay, now with the same reasoning, this is a line from here to here, right? This is 150, so this is 30. The internal angles of a triangle is 180 degrees. So that would make this one 80. And this one also 80. So we're going to have, this is theta. In front of theta, we'll have another theta here. So we're going to have 2 thetas plus 2 of this 160 will be 360. Okay, so you will see that the theta is 100. And there you go, that's the answer. The shaded square is inscribed in the larger square is shown. What is the ratio of shaded to unshaded area in the diagram? So this is 3, this is 4, and of course this is a right triangle, which makes this one 5. This one is 5, this one is 5 because it's a square. So the red area will be 25, which is going to be the shaded one. So the shaded one is 25. What is the area of the biggest square? It's going to be, this is 7. If this is 7, this is also 7. It's a square. So the full area of the square is 49, but we shouldn't make mistakes, right? Because here it says shaded to unshaded. The area of the unshaded one will be 49, the biggest square, minus 25, which is the red one, is 24. So this B would be the answer. Okay, I think it's easy, but you could make a mistake. Question 7. Jemmy multiplies together all the numbers from 1 to 18. What are the last 3 digits of the result? Okay, I have to do just a little teaching here before I give the answer. Well, we know that 2 times 5, okay, is going to be 10, right? But if I give you 2 times 5 and a lot of other numbers, like I multiply by 3, and then I multiply by 7, then I multiply by 99, what would be the last digit? Okay, the last digit would still be 0 because here we have a 2 and a 5. Okay, but to this multiplication, if I add another 2 and another 5, what happens? Here, you could do it on a calculator if you like. So if I add another 2 and another 5, then the last 2 digits will be 0. So it's going to be blah, 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 0 and 0. So for each 5 and each 2, a 0 is created. Now Jimmy would go on, okay, and multiplies all these numbers. It's going to go like 1 times 2 times, okay, we have to count the number of 2's and the number of 5. The smallest number would define the number of zeros. So for example, so here we reach to 5, that's 1 5. And 10 is 5 times 2 will give another 5. So 15 will give us another 5. We'll end up with 3 5s. Okay, and do we have at least 3 2's? Obviously. 2 years here, 4 will give us additional 2's. 8 will give us another 3. So there are a lot of 2, okay, over here. But maybe 2 to the power of 15. So I don't know, I didn't count. Okay, but we'll have 3 5's. So the last digit will definitely have 3 zeros at the end. Okay, so it's going to be A. Question 8. If fuel tank is 40% empty, so this part is 40%. Now, which percent is full? Obviously, it's 60% full now. Okay. Then 4 liters of fuel is removed. The tank is now 40% full. So that means it's getting lower. Okay. Here we had 60% at the beginning. Now we have 40%. So what percentage did we lose? Okay, 20% is lost. Okay. So now this 20% which is lost is equal to 40 liters. How many liters are in a full tank? So 20% of something is 40. What is all of that? We know that 20%, I could write it this way in case you've forgotten it. So it would be 1/5 of something is 40. So we have something is 5 part, 1, 2, 3, 4, and 5. So 1 part of it is 40. This is the simplest I can just go. And we have 5 of this. So it's going to be 5 times 40, which will be 200. Okay. So the volume V of a sphere of radius r is given by this formula. For a sphere of volume V is equal to 100. Which of the following is closest to the radius? Okay. So we're going to assume pi is equal to 3. if that's the case, so we're going to cancel this 3 by this pi. So it's going to be 100 is equal to 4r cubed, dividing both sides by 4. Okay, we're going to get 25 is equal to r cubed. Okay, so now if r is 3, okay, if r is 3, right, I'm going to go here. So if r is 3, this side will be r cubed will be 27. But this is 25, so r is going to be slightly less than 3 to get this 25. Okay, so the only one that is slightly less than 3 is this 2.9. If I add 3 consecutive odd numbers, I get a total of this. The largest of these 3 integers is, okay. Now let's just see here. If we have 3 odd integers, any of them, so like 5, 7, and then 9, you'll see that the difference is always 2 between these two, right? 5 plus 2 is 7, 7 plus 2 is 9. So that's the only thing we need to know to answer this question. The rest, I would say, just guess. That would be the one. Like, for example, let's go with 3m. So 3m would be the largest of all. Okay, then the one before that is going to be 3m minus 2. And then the one before that is going to be 3m minus 4. Okay, so now what is the total of this? When we add them, it's going to be 9m minus 6. So definitely, okay, they're not the same. So this one is definitely not the answer. So which one is it? I think it's kind of obvious. So if we have, if 3m plus 3, the last one, is, okay, the largest, as the question says. So the one here would be 3m plus 1, and then we go back 2, it's going to be 3m minus 1. And when we add all of these, you'll see that these two will cancel. So we're going to end up with 9m plus 3. So there you go. Question 11, the value of this is equal to which one? We know that a plus b squared, like this, will be a squared plus b squared plus 2ab. Now the first term is a, the second term is b. When we square them, they cancel out the square root. So a squared will be 24. B squared will be 54 plus 2 times square root of 24. Sorry. So the square root of 24 multiplied by square root of 54. I think another one is coming too. Okay, so here, let's see this part. These two together will be 78 plus 2 times of. This one, I'm going to write it as the square root of 8 multiplied by square root of 3. Okay, 54 is equal to 2 multiplied by 27. So I'm going to write it as the square root of 2 multiplied by square root of 27. Okay, and now we know that when we multiply, order is not important. So I'm going to multiply these two first. So it's going to be the square root of 8 multiplied by square root of 2 is going to be square root of 16. So I'm going to write 78 plus 2 times the square root of 16 multiplied by. Now these two together, the square root of 3 and the square root of 27. Okay, so it will be a square root of 81. Okay, so we know that the square root of 16 is 4, the square root of 81 is 9. So it will be, I'm going to write it here, 78 plus 2 multiplied by 4 multiplied by 9. Okay, so this will be 3672. So as you see, it's going to be 150 over here. Okay. In a group of 6 people, there are 3 pairs of twins. How many 3-member committees can be chosen that do not contain any pair of twins? I think one of the options should have been 1. That would also be deceiving. But again, so we're going to have 6 people. Okay, so A and A prime, okay, are twins. Okay. B and B prime are another twins. C and C prime are another twins. Okay, you have to see that I can write A and A. See, if you write it like this is not correct because twins are identical, but they're 2 different kinds of humans, like they have different names, right? So now we're going to get a committee of 3 members. You can't, if you put A here, A prime cannot go here. Okay, so that means we have 3 groups. From each one person should join this committee. Okay, so here we'll have 2 options. Here we have 2 options. Here we have 2 options. So it's going to be 2 times 2 times 2. Okay, so the answer will be 8. You could also keep writing a list. Okay, so for example, if you have A, B, C would be one of them. Okay, so, and then A, B prime, and C would be another one. Okay, now the solution number 2, okay, it's going to be A to power of -1 is going to be 1 over A minus 1 over B. Okay, the big fraction line. And this one will be 1 over A squared minus 1 over B squared. So this now has to remind of something. There is a negative and both of them are squared. Immediately you have to think about this. X squared minus y squared is equal to, okay, x minus y multiplied by x plus y, right? Now in our case, 1 over A is x. So 1 over B is y. So let's just go and replace the new values. So I'm going to go 1 over A minus 1 over B. So now this one, it will be, once we add these two, 1 over A plus 1 over B, multiply by, once we minus them, subtract 1 over A minus 1 over B. So you would see that this one and this one are equal, so we'll cancel. So it will be 1 over A plus 1 over B. Is this in the options? No, so we have to simplify it even more. So what is 1 over A plus 1 over B? Okay, remember, if you get confused anytime, replace them by numbers and just review the steps. So if I ask you what is 1 over 2 over 1 over 3, then what do? You just go 2 times 3. So you multiply these two. So here will be AB. Now here, what do you do here? You'll go like 3 minus 2. So it will be B minus A. So instead of this, I'm going to write this. So it will be 1 over B minus A over AB. Okay, which will be equal to the reciprocal of this. So AB will go on top. Oh, by the way, sorry guys. So here I made a mistake here, a plus b. So this would be plus. Okay, so here is also a plus. Okay, so it will be over a plus b. Okay, which is going to be the option C. So I think the number one, just guessing some values, working with that was an easier way. A bag contains red and yellow balls such that the ratio red-yellow is 5 to 7. Then 10 balls of each color are removed and the ratio changes to 5 to 8. How many balls were originally in the bag? So again, if you want to solve this question, it would be a bad idea. Let's just do some guesswork. So I'm going to go with the middle one because maybe later I know that I have to go this way, lower or higher. Okay, so if the middle one, if the original number in the back were 72, so how many of this and how many of this do we have? Is going to be 72 divided by 5 times 7. It will be 6. So that means we had 30 of red, okay, and 42 of this. I just multiplied 6 by 5 and 6 by 7. Okay, now it says 10 are removed from both sides. So it will be 20 and 32 after I remove 10 from all of them. So let's simplify both of them by 4. This would be 5. Okay, and this will be 8, which is the answer. There you go. So I just really guessed it right away. So if I was not lucky, like this one, I would go with 84, or I'll go with 60. Okay, then we find it. So let's do it with 60 and see why 60 is not the right answer, but 72 is. So if we had originally like 60, we can do some cleaning. Okay, 72 is the answer. But if we choose like, let's just try 60. Then 60 over 5 plus 7 would be, okay, 5. So that means initially we had 25 reds and we had 35 of this yellow thing. We remove 10 from both of them, will be 15 and 25. Dividing both of them will be by 5 will be 3 and 5. So as you see now, the ratio is 3 to 5, not 5 to 8. So 60 is not the answer. And 72 is the right answer because I was lucky. In the solution to this number puzzle, whenever there are 3 numbers in a straight line, the middle number is the sum of the other 2. What is the value of x? Okay. So A is the sum of this plus the sum of this. I think if you saw the previous questions, then you know how we answer these types of questions by coming up with different values. So I will assume C is 3, X is 1, then this one will have to be 2, okay. I would guess this one's 0, so B becomes 2. A will be the sum of 0 and 1. So whichever is the right answer, okay, we'll have to work with these numbers too. Okay, so if A is 1 plus B is 2 plus 3, 1 plus 2 plus 3 is 6, divided by 2 will be 3, but we know X is 1, so A, goodbye. So B is 2 minus D will be negative, goodbye. So now this one, A is 1, B is 2, minus 3 will be 0. Okay, so C will be 0, but we know X is supposed to be 1. Bye-bye. D, this will be 2 minus 3 plus, wait, I got confused. So A was 1, minus B is 2, plus 3, okay? All of this multiplied by 1 over 2. So as you see here, this would be positive 2 multiplied by 1 over 2 is 1. So D is Okay, but let's just check E. So B plus C, okay, will be 5, minus 1 will be 4. 4 multiplied by 1 over 2 is 2. So this one is again not the right answer. So the only one that could be the answer is one of them, D. So we're pretty sure D is the right answer. If fx is equal to 5 plus x and gx is 7 minus x, what is this expression? So to create f of gx, okay, what we're going to do here, I'm going to write this fx is 5 plus x, but instead of x, we're going to put gx, which is this one. It's going to be 7 minus x. So we simplify it. It's going to be 12 minus x. So the first thing here is 12 minus x. Okay, now let's go create, okay, g of x. So how do we do this? Okay, gx is going to be 7 minus x, right? But instead of x, we write fx. What is fx? This one. I'm going to write 5 plus x. So this one is equal to 7 minus 5 minus x. So it will be 2 minus x. So this one will be 2 minus x. So we again going to subtract them. So it's going to be 12 minus x. Okay, minus 2 minus x. Okay, it will be 12 minus x. This negative 1 is for both of them. It's going to be negative 2. Negative x is positive x. So now you'll see that this negative x will cancel this positive x. So 12 minus 2 is equal to 10, which will be D. Okay, the hypotenuse of a right angle triangle has length 6. The perimeter of the triangle is 14. What is the area of the triangle in square centimeters? Okay, this one is the first, I would say, extra challenging question here. This is different. I think it will be difficult for a lot of the students, even though if it's only question 17. Okay, now here it says that this is 6. Okay, and we know that if I'm going to call this one A, this is B. So we know two things. We know that A squared plus B squared is equal to 36. Okay, and we also know that the perimeter is 14. That means A plus B plus 6 is 14. So A plus B is equal to 8. Okay, now the weird thing about it is that if you try to find A and B, they will not be integers, right? So if you try to guess them, it's impossible. You just have to know that what we really are looking for is half of AB. We're not trying to find A and B. Okay, this is what we really are trying to do. And after this, we no longer need this triangle. So I'm going to remove it here. So we just have to solve this now. Okay, so it's not going to be difficult. All we have to do is have A plus B squared, okay, is equal to A squared plus B squared plus 2 times AB. Okay, so we know that A plus B is 8. So this is 8. A squared plus B squared will be 36. Okay, so there you go. We just can't find AB. So this will be 64 is equal to 36 plus 2 times AB. So from here, we're going to have 40, 24, 28. So 2 times AB is 8. Okay, so AB is equal to 7. 14. Okay, and now we want the area of, the area was AB over 2, which will be 7, which is going to be option A. I have 2 identical dice, each with these faces. I roll both dice and multiply the 2 numbers rolled, then simplify my answer. What is the probability that this product is rational? Okay, let's see, for example, if I multiply 1 over 2 by 1, it will be again 1 over 2. Is it rational? Yes. So as long as there is no a square root of 3 or a square root of 2 in the answers, it's rational. If I have a square root of 2 or a square root of 3, irrational. So for example, what if I multiply these two together? I'm going to get square root of 3 over 2 times the square root of 2. Definitely irrational. Okay, so now let's go and answer the question. We have the total possibilities is 6 times 6, which is going to be 36. Now, pay attention if we add 1 times 1, rational. 1 over 2 multiplied by 1 over 2, rational. Square root of 3 multiplied by square root of 3 is 3, rational. And the same thing goes on. For example, the last one multiplied by itself is going to be 3 over 4, which is equal to 0. It's actually obviously rational. So any number multiplied by itself is rational. Plus, now what else? You see 1 and 1 over 2. Okay, what else makes it rational? Square root of 3 and 1 over square root of 3 is again another one. And this one and the last one is square root of 3 and the square root of 3 over 2 is again another one. Okay, and these two would the last one. So 1 over square root of 3 over a square root of 3 over 2. If you go on and like write 6 plus 4, there you go, you got the wrong answer. So why? Because each of these will happen 2 times. Okay, maybe the first dice is 1, the second one is 1 over 2. Maybe the first one was 1 over 2, the other one was 1. So each of these have 2 times chance of happening, right? Maybe the first one is this, the second one is this, or the other way around. So plus these 4, each one multiplied by 2. So this will be 36. This will be 14. You simplify it, you're going to get, okay, 7 over, let's see, 18, which is going to be the last one, B. How many distinct pairs xy satisfy this inequality if x and y are both positive integers with x greater than y? Okay, so the first thing here says both of them are positive, okay? So that means 0 will not be one of the numbers and x will be larger than y. So I think we just have to make a list knowing that, well, the options are not too many. So let's go and do this. I want to just start with the largest x being 7. And how about this? Can x be 7 and y 1? It will be 50, okay? So, but it's supposed to be smaller, so this is out. Okay, so we can't have 7 here. Let's just start with 6, okay? X being 6, y being 1 becomes 37 is smaller than 50. Okay, 6 and 2 becomes 40, still smaller. So here, 36 and 9 is 45. 36 and 16 is larger than 50. Okay, so with 6, we have 4. Now let's go in here. Obviously, 5 and 1 will work. Okay. So 5 and 2, 5 and 3, even 5 and 4 will work, right? Because it's going to be 25 plus 16, still smaller than 50. Okay. Can we have 5 and 5? That would be exactly 50, but again, x wouldn't be larger than y. So now we're going to go with obviously 4 and 1. So 4 and 2 and 4 and 3. Okay, so it's going to be 4 and 3. Then it's going to be x being 3, y being 1, and 3 and 2, and lastly 2 and 1. This is all of them. I wrote all of them. So we just have to count. This is 4. This is another 4. This is a 3, a 2, and a 1. So 3, 3, 6, 10, 14. So we have 14. That means we have missed one of them. So 6 and 5 wouldn't work. 6 and 4. By the way, sorry, I said that this one is out. I don't know why I wrote it here. Okay, because I said that's going to be 36 plus 16, so it's going to be larger. Okay, so this will be out, making this 3. Okay, this one, let's double check this one. 25 plus 16, obviously smaller. So a 3, a 4, a 3. So that's going to be a total of 13. A 15 by 20 centimeter rectangle is cut into 2 triangles. One triangle is rotated and placed at the top of the other triangle as shown to form a concave pentagon. What is the perimeter of the pentagon? Okay, so here, let's just start by this. See, obviously, if I ask you, okay, we have a triangle like this. So this one is, for example, this is a 3, this is a 4, and you will jump and say, this is 5. And you're right about it, okay? So, but I see a lot of students when they give them 15 and 20, says, whoa, I need to calculate this. No, we don't. Okay, see that the ratios are actually the same, okay? So this is 3, 4, and 5. This one, the red one. This one is 15, 20, and the last one will be, see how each one has been multiplied by 5? Okay, so the last one is 25. So what we're going to have is actually this line is 25. Also, this one is 25. So we have this. Now the next thing is this little triangle. So how large is this? Okay, this is 15, right? In this triangle. Now, if you pay attention, this 15 is the hypotenuse for this triangle. But what you should also notice that this is also similar to the other triangles. Okay, so why is this one similar? See, this angle is common between this one, this triangle, and we color it, and this one. So both of them have, of course, the same angle, and both of them have a 90 degree. So the third angle is also the same. So because both of these triangles have the same angles, they're similar. Okay. So if this one is 15, this was the hypotenuse, okay? So here the hypotenuse will be 15, okay? This has been multiplied by 3, 4 multiplied by 3, 3 multiplied by 3. So what we're going to have is that this is a 9, and this is a 12, and that's exactly everything you need. So the rest is just, you have to count. So let's just not make a mistake here. This one was a 20, okay? This is also a 20, okay? So this is the smaller side, is a 15. Now this one we had earlier, this was 25. 25 minus this 12, this is a 13. And for this one, 25 minus a 9 is a 16. So you just have to sum all of these numbers up. So 55, okay, 71, 74, and 84. We're just gonna be. I have four numbers. When I add 3 to the first number, subtract 3 from the second number, multiply the third number by 3, and divide the fourth number by 3. My four answers are all equal. My original four numbers added to 32. What is the sum of the largest two of these numbers? Okay, so if you see this question and the first thing you do is writing an equation, you're not thinking right. This is a test. This is a speed question, okay? So equations are not the way to go. So you just have to pay attention that one of the numbers, they all become equal, right? And the third number is multiplied by 3, and they're all equal. So that means the number that we're looking for is a multiple of 3. It's divisible by 3. And when we add them is 32. So what number would you guess? Maybe 9, right? So the four numbers at the end are 9, 9, 9, 9. Let's check, okay? If originally they were 32, so question solved. So one of them has to be multiplied by 3, 27. One of them divided by 3, 30. As you see here, this one minus by 3, 6. This is already larger than 32. So 9 is not a good guess. So let's go make it smaller. So at the end, we'll have 4 6s. Okay, let's multiply one of them by 3, 18. Divided by 3, 2. Add 3 to it, 9. Subtract 3 from it, 3. So when we add them, okay, so 12 plus 18 is 30, 32. So that's the end of the question. And this is question 29. It has 5 marks. Okay, so what does it want? The sum of the two largest, 18 and 9, 27. You could do it under a minute. Antonio walked 11.5 kilometers to his cousin Maria's house. At first, he walked uphill, then along a flat part of the road, and the final part was downhill. The trip took 2 hours and 54 minutes. The next day, his walk back home took more time, 3 hours and 6 minutes. Antonio walks uphill at a constant speed of 3 kilometers per hour, on the flat part at 4 and downhill at 5. What is the length in kilometer of the flat part of the road? So first, how is that even possible that you go a path, you come back, the times are different? So on the way that he's going is going up, he goes the flat part, and the downhill part is larger than the uphill part. So when he comes back, okay, it will take him more time, okay, to do that. So we're going to call this part, the first part, A kilometers, B kilometers, and C kilometers. Okay, so we're going to have A plus B plus C is equal to 11.5. Okay, so he goes A uphill on the way to M's house. So it's going to be A over 3, very slow. And then B part with the speed of 4. And then C part with the speed of 5 because it's downhill. When he does so, it's going to take 2 hours and 154 minutes. That's going to be 174 minutes. Okay, I'm going to write it like this. Okay, so on the way back, the C part is going to be uphill with the speed of 3 plus B will be constant as you see. And now the last part, A over 5. Okay, so it's going to be 103 hours and 6 minutes, 186 minutes. I'm going to write it like this. So we have 3 equations and we need to solve this. We have 3 variables, 3 equations possible to solve, but it's not going to be that quick. So both of these equations, I'm going to multiply them by 60. So it's going to be like this. We're going to have 20a plus 15b plus 12c is equal to 174. And here we're going to have 20c plus 15b plus 12a is equal to 186. Okay, so it's better if we got rid of all these fractions. So now, okay, we need to get rid of c maybe, right? So to get rid of c from the first equation, okay, I will multiply all terms of this by 12, and then this one minus this one will get rid of c. Let's go and do this, okay? So I'm going to multiply, let's keep it here. So it's going to be, again, 20a minus 12a is going to be 8a. So I'm going to write it here. Okay. 15b minus 12b, 3b. Okay. Minus this, okay, it will get rid of c. So here will be 174. Okay, minus 12 times 11.5. So it would be 23 times 6, 138. Okay, good. So now this time, I'm going to repeat the same steps, but this time to get rid of c, okay, I'm going to multiply this by 20. Okay, we'll create 20c here, and then subtract it from here. So when we do this, 20a minus 12a is going to be 8a again. So, and here we'll have 20b minus 15b will be 5b. Okay, and c's will be canceled. This will be 186. Sorry, I did it like this. So it's going to be 230 minus 186. Whew. So we no longer need these, or actually this one anymore. So 174 is going to be 36. So let me write it here. It's not working. Okay, 36. And this one will be 14 plus 30, 44. So you would see it here that all you have to do is, because both of these equations have 8a, so we just have to subtract them. We're going to get 2b is equal to 8. Okay, so b will be 4, which is going to be option A. So this was a rather long question. I think skipping it in a test or doing it later in the test would be a wise thing to do. Question 23, I think of 2 positive integers and call their sum s and the product p. Which one of the following could not be the value of s plus b? So let's imagine that the first number is a, the second number is b. So we're trying to find ab plus a plus b. Okay, so it could take form of any of these numbers, but except one of them. Let's see which one that is. Okay, now when we look at the options, we see that all of them are even numbers, so no odd numbers are on the list. So we have 3 possibilities. Maybe both numbers are odd, one odd, one even, or both even. See if this one is, for example, odd, plus another odd will be even. Two odd numbers multiplied becomes another odd. When we add them, they become an odd number. So that's not possible. So how about one of them even plus odd? It would be odd. This will be even plus odd, so not again possible. So, and then the last thing we realize is that both of them are supposed to be even numbers. So let's assume that one of the numbers, let's start from the smallest. If A is 2, so let's come up with a number B that would result in some number around this range. So maybe 20, not enough. So maybe 24, 48. Okay, let's see if it's enough. A2, B24. This will be 48 plus 2, 50, 74. Not on the list. So let's make it a little larger, like 30. So 2 times, if we do this, 60 plus 30 plus 2 is 92. So 92 is out of the list. So let's try another number, something smaller. I'm going to go with A2, B28. Okay. So will be AB will be 56 plus 28 plus 2. It would be 86, right? So 30, 86. Yes. So see, 86 is also out of the list. So if I make it 26, I think it will be too small. So I wouldn't try that. Instead, I'll go with A being 4. Okay, and I'll come up with another B. So if A is 4, I'm going to go with B20. Let's see what I get. It's going to be too much. So how about 18, 72 plus 76? So now 4 times 18 plus another 18, 94, it will become not useful. So let's go with another one. So now AB will be 64 plus another one. It would be 84. Okay, so here you see that if I go like this, 16 times 4 plus 16 plus 4. Okay, it would be 84. So this is also out. So I just need one more. So let's make this a little more. If I go with 18, what happens? 90 plus 494. Not useful. So I have to change this into 6 then. What if A is 6 and the other one is 12, for example? So it would be 12 times 6 plus another 1 plus another 12 plus another 6. So it would be 84 plus 4, 90. So 90 is also out. So what we are left with is 88. A solid regular tetrahedron has 4 faces, each an equilateral triangle. So all the sides are equal. It is suspended in the entomology laboratory. There are 2 food sources on the tetrahedron, one at the vertex V and the other one at X, the center of the opposite face. When this worm, I'm going to call it worm, is placed anywhere upon the tetrahedron, it instinctively crawls along the shortest possible path over the surface to the closest food source. What fraction of the surface area is closer to V than to X in terms of path along the surface? So first, what does the question mean? Okay, this is a tetrahedron. There is a worm, and the worm will go to the closer food. One of them is at one point here, and in front of it, on the opposite face, is another one. So the worm would go to the closer one. So now, so randomly, we could put the worm anywhere. Is it more likely that it will go to food X, or is it more likely that it will go to food B? And we know this likelihood by the surface area, okay? So we want to know what fraction of the surface area is closer to V than to X in terms of that. So you would see that the answer also suggests that the worm is more likely to go to grab this food than the other food. Okay, so now how to deal with a question like this. Okay, so I have to highlight these so that you could follow whatever I say. So I'm going to make this purple and larger. Okay. So this one is purple, and the one below it, I'm going to make this one red. The reason I do is because I want to do something here, right? This would be the red, okay? And I want to draw it again, okay? But I want to like open this and draw it again. So let's do this together. I'm gonna just remove everything. Let's leave the question because we're gonna need that. So if I draw it again, right, the purple one would look like this. Okay, equilateral. And the one below it, I'm going to, okay, it's this one, right? Okay. And a food source, right? One of them is at V, which is going to be the tip over here, V. And the other one will be right over here in front of it, okay? Okay, and the next question is, we have 4 faces. So how many of these red ones do we have and how many of these purple ones? We have 3 of this, okay? This one, and this one, right? But we only have 1 of this one, okay? Now let's just, the worm is green, I'm gonna make it green. So if we put the green worm at any of here, even if we put it on the side, it's definitely easier to grab the food on X, which is this one. So from one of the forces, all of this area is for X, okay? Now let's see, for example, what if the food, however, is right over here? Again, you would see that it's closer to this one, so grab X. Okay, now where is the line, right, that it would be equally close to both of the foods? We're gonna find that. Okay, so first of all, we know that this point, okay, is the centroid. Means if I draw this one, draw this one, draw this one, it would be the centroid. And we know that if I go and call this one height, if this is height, h, so from here to here, this little bit is height over 3, this little thing. I will have to draw it with a different color. So the blue one. So this will be h over 3. Why? Because it's the centroid, okay? So it would be this one now. Now, which one is closer? So if I have the worm being here, right? So for example, right over here, which one is it closer to? This is the most important part of the question, okay? Pay attention. See, if I want to go, if it wants, the worm wants to go to the x1, to the one below, it has to go like this, to the right, and go all the way down, 2 vectors, right? If it wants to go to the one on top, it has to go to the right, okay, and then go up. You would see that the portion that is going to go right is equal, right, for both of them. So what determines which food it grabs is actually the vertical distance only. And it has nothing to do if it's right or left. Okay, the vertical distance. Okay, so with that information, okay, I have to come up with a new color. So it would be exactly this line over here. Okay, why? See, now this line over here, let me make it green. So from here, this distance from here to here would be, okay, 2h thirds. This one will also be 2h thirds, will be equal. This one also 2h thirds, right? So if it goes above that, it's going to go to V. If it goes below that, it's going to get to there. Okay, so now, basically, so all of them, for all these three parts, I'm going to go back to the main picture, make them purple. It's going to be like, for all of these, if it's above this line, kind of like this, okay? So if it's in this area for this one, this area for this one, okay, it's 2/3 of the height, it will go to V. So you just have to calculate this. If it's in the like bottom face, it will always go to X. Okay, these areas are also for X, the ones that are below it. Okay, so all we have to do is find this area. Okay, so we know this one. What is the area, the ratio of the areas? Then we have to do this. So I'm going to clean this and draw one more over a triangle like this. Now, if the height is 2/3 like this one, what is the ratio of the areas? Okay, so we know that this area to the big area is going to be 2/3 squared. So it's going to be 4 to 9. Okay. Now, for simplicity, because it's a ratio question, we're going to assume that the area of each of these triangles is 9. The top part then will be here, will be 4. The one that is below will be 5. Okay, so that means we're going to have, this is a 5. It will go to X. Okay, there's also another 5 here. There is on the back side, there's going to be 4, the ones that will go to X. We have 3 of this. Plus, if it was on the bottom face, the red one, it would directly go to X. So it would be the portion of the area that would go to X, which is going to be 15 plus 9, 24. Okay, now the areas that will go to V, it was 4, remember? This area was 4. Let me highlight it. This area was 4, and we had 3 of this, okay? Screen. So 4 times 3 will go, okay, to V. Now what does the question want? What fraction of the surface area is closer to V than to X in terms of pathway along the surface? Okay, so it's going to be like this. So from 12 is the area that is closer to V, and the total area, you could just go like 24 plus 12. It was also this part unnecessary, so I did a little extra. We didn't have to, because we assumed that this area was 9 and this is a tetrahedron, so we have 9 times 4. So I did a little extra. So it's going to be 12 over 36. It was 1 over 12. Sorry, 1 over 3. Okay, so it's going to be B. See, one thing, it wasn't a really difficult question, right? So all you really have to do, come up with this 4, and each side is 9. We have 4 of it, 36. This area is 4, and we have 3 of it times 3. That's going to be a third, right? But the whole thing was understanding it and analyzing it, and I hope I was clear and you managed to understand the question. Three spheres of radius 2 sit on a flat surface touching one another. A smaller sphere sits on the same surface in the middle and touching all three of the bigger spheres. What is its radius? Okay. Now, first of all, personally, I find this question most difficult of all the 30 questions. And if we see the spheres from the top-down view, they turn into 4 circles like this. And if you connect the centers of each circles, we're going to have an equilateral triangle. Okay. How large is this? It's going to be 2 plus 2, 4. Okay, so each side is 4. Okay. And now we see that the center of the red circle will be the same distance from each vertice, from each point. So making that the centroid of the triangle. Okay. And in the previous question, we saw that we used that if all of this is H, change the color. If all of this is H, so for example, from here to here, if we call that H, from this point to this point will be 2/3 of H. Okay. Okay. So we have 4. It's very easy to find this, but and then we could find that. So once we minus it, when we look closely, this is also 2. So we find 2/3 of H, minus it with 2, we find this R right over here. Is that the answer to the question? Is it so easy? Well, I don't think so, not like this. Why? Because let's see it from this point of view, okay? Now this is the ground. Okay. So if we see it from this point, okay, we'll see that they don't have the same height. So let me show you something here. So for example, now this one from the center, this one to here is 2. But the height of this one is actually from here to here is only R. Okay. So now if I want to draw this line, look. So let me highlight this. So from here to here is this line. Okay. This line is actually like this. Because when we see it from the top view, it looks like a line like this. It's not. Okay. So we're going to have 3 sides like this. Okay. Now you will see that this difference in height will turn this triangle into a tetrahedron because it has a height. It's going up. Okay. So, but in this case, it's actually going down. But let's see here. So, how to actually find this, right? If it's a tetrahedron, I'm going to draw a tetrahedron now. Okay, let me do my best. So these are going to be the black ones. Okay, each side will be 4, 4, 4. It's the black one over here. But these orange ones are going to be like this. Okay, when you see it from the top view, you will see a triangle like this. Okay, so now how large is this orange one? You will see that this part is 2. So the orange one will be 2 plus R. Okay, the red radius, the red circle's radius is R, 2 plus R. So I'm going to write here with orange is going to be 2 plus r. Okay, but we also need the height. So if we go, I want to make this yellow. If I go make this 90 degrees, okay, right over here, okay, it would be exactly this line over here. Okay, so now how large is this yellow one? Again, you would see it. This is going to be from here to here is 2 minus r. So the yellow one is actually 2 minus r. Okay, so the last thing, I hope you can see it. The picture is not. So from here to here, what is this green one? Okay, this green one, okay, will be exactly what I said at the beginning. Okay, 2/3 of this distance. Okay, so from here to here. Okay, but the one below it. Okay, so the line exactly below this orange line is one that is horizontal. Okay, so this green one will be, we have to do it like this. So let me just draw a, maybe I could do that. Okay, now each one is 4. Let me make this one black. 4, 4, 4. So from here to here, now we need to find this. This is the green line that we need. So from any of the vertices all the way to the centroid. Okay, we're going to need this. To find this, first we need to find all the way down. So let me make this black. So we need it all the way. So I'm going to just draw it like this. Okay, so this one, to find this one, this is 4, half of this is 2. Okay, so this line, the black one, this one from here, is going to be a square root of 4 squared minus 2 squared, which would be square root of 12. Okay, so now from there, if I go all the way, from here to here is a square root of 12, but I want to go only to the centroid, so it's going to be 2/3 of that. So now this one is 2/3 of the square root of 12. Now these together, pay attention now. This is a right triangle. Maybe I could just redraw it again to make sure everybody understands. So this, I will redraw everything. So there will be this green one going like this, which is 2/3 of a square root of 12. There is a height. There is a height of 2 minus r. And there would be the hypotenuse of 2 plus r. Okay, so we just have to write an equation, okay? So we're going to use Pythagorean theorem, and when we do so, we're going to find the value for r. To do that, let me do some cleaning. So it will be 2 minus r squared plus 2/3 square root of 12. All of this is squared is equal to 2 plus r squared. Okay, so I'm gonna just write it here. It will be 4 minus r squared plus r squared minus 2 4r plus 4/9 of 12. So this will be 3, this would be 4, it would be 16 over 3 plus 16 over 3 is equal to, now this one, 4 plus r squared plus 2r. So, and then this 4 cancels with this 4, r squared are cancelled. So, by the way, this is not 2r, this is 4r. So we're going to have 16 over 3 is equal to 8r. Okay, so we're going to have r is equal to 2/3. Okay, so it will be E right by my head, right over here. Well, I think this question was extremely difficult. So maybe there is a better way of doing it. So if you know a better way of doing it, write it in the comment section. How many ways can you select 4 distinct equally spaced number from the set 1 to 40? I think it's a easier question than the previous one. So we just have to be careful not to make a mistake. Okay, so because that's equally spaced, so the smaller one will be, okay, 1, 2, 3, 4, and each one is being plus by 1. So the next one will be 2, 3, 4, 5. And if we continue like this, the last one will be 37, 38, 39, and 40. Okay, so the distance between each one is 1, 1, 1. Okay, so how many sets? Okay, have I written here? So it's going to be from 1. The last one is 37. So far is a 37. I'm going to write it right over here. Okay, the next one, I have to jump plus 2. Okay, so it would be 1, okay, 3, 5, 7. Okay, now what would be the last one to do? It will be 40. I'm going to go backward. 38, 36, 34. So the beginning one is 1. The last one is 34. Okay, so we're going to have 34. So I'm going to write 34 right over here. So see if we can come up with a pattern. So I'm going to clean this. Now from the beginning one plus 3, it's going to get 4, 7, 10. The last one is supposed to be 40. So let's go back. It will be 37, 34, okay, 31, which would be the last one. Okay, so it will be 31. Okay, so you would see that each number is being minused by 1 by 3. So the question is actually the sum of these numbers. So I'm going to write it 37, 34, and then minus 3, 28, okay, and then 25, okay, 22, okay, 19, 16, 13, 10, 7, 4, and 1, okay. So in case we wonder, what is this one that is only 1, okay. So we'll continue on the list. I think it will be 1 plus 13, right? So it'd be 1, 14, 27, and 40. This is the last one. If we continue all the way, so this one belongs to this. So we just need to find the sum of all these numbers, okay? So it's going to be 31, 37 plus 1. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But this number divided by 2, that would be the sum. So this equals to 38 divided by 2, 19, multiplied by 13. So it's equal to 260 minus 13, 247. Okay, question 27. Digits A, B, C are chosen, and then two 6-digit numbers are formed. M with digits A, B, C, A, B, C in this form, and N with digits A, B, A, B, A, B. The ratio M to N is 55 to 54. What is the 3-digit number A, B, C? Okay. Now, okay, we know that, okay, whatever these numbers are, okay, for example, this one, A, B, C, A, B, C, we divide it by a number, okay, they have been simplified into this, right? So they have been divided by a number, X, and then this one has become 55. The second number, AB, 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 when we divide it by, again, the same number, we call it X, will be 54, okay? How do we know this? Okay, because they have been simplified like this. These are huge numbers. Both of them have been simplified into this, okay? Now, we could also say it the opposite way around. If ABC divided by X is 55, so ABC is also divisible by 55. So that means ABC, this number, is also divisible by 5 and 11. So any number written in this format is divisible by 11. Okay, because see, if you add odd numbers, A plus C plus B is equal to B plus A plus C. So it doesn't matter what number you use, right? Just try a calculator with different number. You see this number is always divisible by 11. But this also says that it's divisible by 5, meaning that C is supposed to be maybe 0, maybe 5. That's the first thing that we know. C is either 0 or 5. Okay, now let's see about this one. AB is supposed to be divisible by 2. Okay. It's also supposed to be divisible by 27. Okay. Not just 9, 27. Okay. So if a number is divisible by 27, okay, is supposed to be divisible by 9. Okay, and then when we divide it by 9 by additional 27. So for example, if I write this number 2, 4, 2, 4, 2, 4. This number is divisible by 9, right? You add all the digits, it becomes 18. But is this number, when you divide this number by 27, okay, you could just use a calculator. You'll see that it's not going to be divisible by 27, okay? So only the numbers that their sum is 9 will be divisible by 27. Okay, so that means the numbers have to be in this format. Maybe can this number, for example, be 81, 81, 81? No, because remember, B was supposed to be an even number. It's supposed to be divisible by 2. So we could say that the number has to be either one of these that are right here. 18, 18, 18, or 72, 72, 72. Okay, and then 3 and 6. 3, 6, 3, 6, 3, 6, 5, 4, 5, 4, 5, 4. These are the only numbers that are divisible by 2 and also divisible by 3 4 times. Not only divisible by 9, okay, but with an additional 3. Okay, so from here you just have to do you have to check these numbers. So first, this number 18, 18, 18, we divide it by 54. We find x, we multiply it by 55. It's supposed to be this number with c being 0 and 5. I will start with the smaller one because it would be easier, but still very long. So 18, 18, 18. I'll just start with this because that's the smallest one. We divide it by 54. Then we multiply it by 55. It's supposed to be in this form, ABC, ABC. Okay, so let's divide this by 2 first. This one divided by 2 is 27. This one divided by 2 will be 9, 0, 9, 0, 9, 0. Okay, let me change color. Okay, this one divided by 3 will be 9. Oof, this number will be 3, 0, 3, 0, 3, 0. One more time, this one divided by 3. This number will be 1, 0, 1, 0, 1, 0. Okay, we have to divide this one more time by 3 and then multiply by 55. This one, I have to write it down right over here. Okay, so 1, 1, 0, 1, 0, 1, 0. Dividing it by 3, it will be 3. This would be 9, 1, 1. Again, 3. Okay. 9 will be 2, 0. Will be 6, 18. So 21. It will be 7, 21. So it will be 3, 3, 6, 7. Now we have to multiply 3, 3, 6, 7 by 55. Okay, let's go. 3, 3, 6, 7 by 55. Okay, 35, a 3 over here, 33, 18, 1, 16. Okay, because this number is again 5, I'm going to put 5 here, 3 here, 8 here, 6 here, and 1 here. Okay, now let's sum them up. So it will be 5, 8, 1, again an additional 1 here, 14, 8, and 1. Okay, this was actually 5. Okay, so you'll see that when we multiply these numbers, it will be 185, 185. Okay, so and it's again like this. We said A was 1, B was 8. 1, 8, 1, 8, 1, 8. It's again 1 and 8. 1 and 8. And C, the value is again divisible by 5, 5 and 5. So actually we're kind of lucky because the smallest one was the answer. And ABC, now we want the value of ABC. It's going to be 185. So maybe there are better ways. I think there are better ways than the way I did it. So if you know anything, just write it in the comment section below.
Question 29. 2 wheels are fixed to an axle as shown. Due to their different sizes, the 2 wheels trace 2 concentric circles when rolled on the level ground. In centimeters, what is the radius of the circle traced on the ground by the larger wheel? Now let's check some fundamentals together. So if I rotate this circle, okay, around its pivot point, like around its center, do you think this circle will start to move, maybe going right or maybe going left? Well, if we say always yes, the answer is not correct. Well, it depends. If there is no friction, okay, and then you start to rotate this, okay, then this circle would start to just go round and round, but it doesn't move, okay? But if there is friction, okay, when you rotate it this way, it also starts to move to the right direction. But the question is, how far does it move? Well, if you go one round, okay, we know that the perimeter of that is going to be 2 pi r. But because there is friction and they are in full contact, so this one, like imagine it, the circle, this is the surface and this is the circle, this one will start to move exactly 2 pi r as well. So imagine that this distance is 2 pi r. So the center of this will start to move 2 pi r like this, okay? Now we know that these two disks or wheels, okay, both of them will go around the circle, okay, but the bigger disk, okay, will go around the bigger circle, okay. So the bigger circle is this one, the smaller one is this one. So now let's imagine this, okay. If this shaft rotates once, okay, the small one will go 2 pi multiplied by 70. The big one will go 2 pi 105. Okay. And I want to write them in a fraction and see. So I'm going to write 2 pi 105 divided by 2 pi 70. Okay. So 2 pi will cancel by 2 pi. And 105 divided by 35 is 3. 70 divided by 35 is 2. So it's going to be 3 over 2. Okay. What does that mean? Okay. That means if we, for example, if the right-hand side disk, okay, this one, if this one rotates once, okay, maybe it goes this much. Okay, it could go more or less. But the bigger one will go 3 over 2 of the same amount. It goes more. How much more? 1.5 more. Then it rotates another time. This one will go a little more. This one will go a little more. So what I can say here, okay, if the perimeter of this large circle is P, I'm going to call it P. The perimeter of the huge one, the larger one, will be 3 over 2 of P. So we know that this circle, that this one goes, again, if this one is P, the larger circle over here is 1.5 of that amount. So the ratio of the perimeters is the ratio of this radius over this radius. So now we know that the small one, okay, will go around a smaller circle, okay, like this one, which is going to be this. I'm showing it like this. And earlier we saw that the perimeter, if the perimeter of the circle it goes around is P, this one, the larger one, okay, will be 3 over 2P. Okay, it's going to be like this. And now we want to find the radius of this circle, right? That's what the question is. And then find the radius of this bigger one. To do that, there's only one more step to find, okay? So this distance over here. I did the same question for senior level, and I forgot that the question meant like a level ground, and I just used here 120, which is not correct. Okay, because 120 is going to be this distance over here. Okay, that's the distance, the perpendicular distance, the distance of the shaft. Okay, this is 120. Okay, it's a little large. Let me make it smaller. Okay, so this one is 120. But what do we really want is a larger distance. It's from here all the way here. You could even see it in the picture that this one is a little larger than that one. Okay, and what I want to do to make this question easier, see, if I lower this and put it here, and we know that here it was making a 90-degree angle, right? It would become, so let me draw it like this. Okay, would become something like this, and this is 90 degrees. Okay, so this line, as we said, is 120. Okay, we want to find this. In order to do that, we need to find this blue one, so this much. Okay, so I want you to think about this. Okay, so this is the radius of the big circle. It was 105. Okay, so from here to here was 70. So I'm going to put it here. And let's see if I move it around here. Oops. If I move this one, this 70 here, see if I can't move it. Move. It doesn't want to move. Come on. So if I put this one over here, you will see that this one is 70, right? I just moved it. It was the radius of this one. So the blue part, it would be the big radius 105 minus the 70. So this blue part over here is this big 105 minus this 70, which is going to be 35. So this one is 35. So what we really need to do, okay, to find this distance, we're going to have this right angle triangle. Okay, so it's going to be a square root of 120 squared plus 35 squared. Are we going to deal with these big numbers? Well, of course not, because both of these numbers, okay, are divisible by 5. Okay, so instead, let's find this, divide this by 5, it becomes a 7. Divide this one by 5 is going to be a 24. Okay, and we're going to find this one, okay, and then we multiply it back by 5, okay, because this one is too large, okay. So when we do this, okay, this one will become 25, right? So I'm going to get, okay, you could calculate it, but this one will be actually 25. So we divide each one by 5, we multiply it back by 5. This one is 125. So this distance is 125 centimeters. So this distance is actually 125 centimeters. Not 120. Okay, now let's write a simple equation. If this radius is actually r, the large one will be r plus 125. Okay, So the small one will become 2 pi r, would be the perimeter of the small one. The big one will be 2 pi r plus 125. Okay, but they're not equal. Okay, this is the small one. The smaller one, if we multiply it by 3 over 2, will be equal to the big one. That's the only equation we need to write. Okay, so let's go and cancel. So this 2 pi cancels with this 2 pi. No, it's good. Okay, so the left side will be 3 over 2r, okay, is equal to r plus 125. Okay, so we're going to have half of r is equal to 125. So r is equal to 250. But remember, this one is the small one. The question is asking for the large radius, this one. So we just have to find r plus 125, which would be 375. Okay, so this is the right answer. I did this question for the senior level, but I forgot that they will tilt because they are on a level ground. So I use 120 over here, but the right one is this 125 because of course, okay, they rotate a little. Okay, that's it.
Martin the gardener has 3 new vegetable beds near the kitchen, laundry, and shed. So we have 3 different unique places, okay? Each year he will plant one bed with T, tomatoes, and with B, and the other one with carrots, C. He needs a schedule for planting that goes for 8 years or 8 summers. To balance the disease risk and soil nutrients, the schedule must follow these rules. A bed that has tomato one summer, if you have T in one of these places, for 2 years, T can't go in that place. And carrots can be in that place, be in a bed that had beans last year. So, okay, if you had B, then you can't have C instead of it. In how many ways can he schedule his vegetable planting for these 8 years? Okay, I'm gonna just keep these rules, okay, in case you want to look at them while I'm doing them. So, and I need space. Okay, so let me make space. Okay, so now, why do you think the question had to say kitchen, blah, blah, blah? Okay, because if it didn't name 3 places, then all these 3 places would be the same, right? So it didn't matter if T was in the first place or in the second place, right? It didn't matter. But now, see, one of them is the kitchen, the other one is garden, the other one is shed. So it's important if T is in the first place or T is in the last place, okay? And how many ways can you put TBC here? Okay, it's going to be 3 factorials, which is going to be 6. Okay, so I'm going to go write one of them randomly. Okay, TBC. Okay, it could be 6 ways. I'm only going to continue this way. Okay, but we know whatever happens with this, it will happen to the other 5. Okay, so without loss of generality, I'm going to just work on this. At the end, we will multiply the answer to this by 6. So if we have TBC, right, like this, okay, so I'm going to write it here because I'm going to need more space. Let me just write it better. So TBC, okay. So now for the next year, okay, T can't be in the first place, can it? Okay, T could be either in the second place or the third place, okay? So I'm gonna put it in the next place, okay? And now we have B in the middle, so C can't be here, but it's already been taken by T. So then C could be either here or here. So actually we're gonna have B, T, C as well. So we have 2 now, okay? So we're gonna have one more here. Remember, T could have been in the last place too. If T goes in the last place, however, you see now B is here, so C can't be here, okay? If C can't be here, C should only be here. So B was here in the middle, B has to be in the middle again. And the same procedure will happen. We have to take the same steps, okay? So first year we had like this, okay? Now this is like the second summer. Okay, we have these ways. So let me change color. Now again here, look, for the next year, for this one, T was in the first place, T was in the middle place, so T has to be in the last place. I'm going to put down T right over here. Okay, T took the place of B. Okay, so C was supposed to not be here, but who cares, right? Because it's already been taken. So again, C could be here, C could be here. So I'm going to write B, C, and then another one, C, B, T. Okay, this one now. Okay, again, T has to be at the end. So T goes to the end. Okay, it didn't take the place of B. So, okay. So here, B has to be here, C has to be here. Okay. Now this one became 3. Now right over here, so CBT, T has to be in the middle for the next year. So T is taking the place of B, so we're going to have 2 BC. And we're going to have another one, okay, TCB. So like, let's see the pattern, 1, 3, 5. If the next one is 7, then we could say, okay, it's just like odd numbers plus by 2. So we just have to do it one more time, okay? So if you see the pattern now, you see for each of these two, okay, this one will gonna give us 2 new ways, okay? These two are supposed to give us 3 new ways. These two are going to give us like in total 3 new ways. So the next one will be actually 8. Okay, let's see how. Okay, I'm gonna do it one more time. So BCT, T has to be in the first place. It took the place of B, so it's gonna be TBC and TCB. Okay, now this one, okay, I didn't write it so well, all right, let me clean it. So this one is the one that gives the only one more. So T has to be in the first place. So B here, C here. As I said, this 2 is going to give 3. This one will give us 2. Okay, so T will go in the first place. So TBC, TCB. Okay, now here, the last one. Okay, I think you get the idea now. But when I write it here, I don't want to write it. That's waste a lot of time. So you could just continue like this. You'll see that it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's going to be 8. So that's confusing, isn't it? So, and now what happens here, okay? So here, when I wrote it like this, this will give 1, this will give 2, okay? So again, the next step, you could continue it here. Each 2, like this, will give 3 more. I'm going to change the color again, back to blue. So these will give us 3 new, these 2. This one that is alone will give us 2. These 2 will give us 3. Now these 2 will give us 3. This one will give us 2. What is the next number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 13. Back to odd numbers. But did you get it? What kind of numbers are these? I'm gonna write it like this with purple. 1, 3, 5 after this one. 3 plus 5 is 8. 8 plus 5 is 13, right? So these are Fibonacci numbers, right? So the next one will be 8 plus 13, 21. Okay. And again, the next year will be 34. And the next year will be 55. It said 8 summers, right? So if we say this is the first summer, okay, and we have all these ways, so it's going to be like 55 at the end, okay? So 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, yes. So after 8 years, if we would TBC, okay, for 8 years we have 55 ways of continuing this like farming bed. Okay, so now, but it was for one of them. Remember at the beginning I said this is for TBC. If at the beginning we wrote C, for example, BT, we'll have 55 more. Okay, so that's why in the first place we had 6 ways to go. This is 55, so the answer will be 55 times 6. So it's going to be 330. Okay, so let's see you in the next question. A percussionist is practicing patterns within an 11-beat bar of music. To visualize this, she arranges 11 dots around a circle, with black dots representing a drum hit. She reads this pattern of dots clockwise, starting at top and top. Her patterns have at least one black dot. Okay. No 2 adjacent black dots and 2 patterns only count as the same if they are the same in every detail, including where the pattern starts in the circle and the direction it is red. For instance, patterns A and B below are 2 of her patterns. Okay. And they count as different even though B can be thought of as A, starting on a different beat. Okay, pattern C is not correct because 2 adjacent black dots are together. Okay, and these 2 aren't the same, even though you see we have 2 white, 1 white, 2 white. It's not going to be the same because the starting position is different. Okay, so with all of this, okay, what is the question? Well, let me finish it. Pattern C is not since. Okay, how many drumming patterns like this are possible? Okay, so let me just tell you before, I think we no longer need this, so let me take it all away. Okay, so what if I give you, for example, 5 letters, A, B, or 6 letters, A, B, C, D, E, F, and I tell you how many groups of 3 letters can you pick? So you could just pick, for example, CD. You could pick AEF. How many ways do you do that? Okay, it will be a combination of, okay, 6 and 3. And how we calculate it is going to be 6 factorials divided by 3 factorials. Okay, and then the last one, 6 minus 3 factorials. Okay, you need to know this in order to understand my explanation. That's it. Okay, now let's begin. To answer this question, we're going to do a casework. The casework is like this. Okay, what if we have only, okay, 1 black dot? Okay, so the black dot could be here, it could be here, right? It could be any of these circles, and the rest will be white in our case, like purpley. Okay, so if we have only 1 dot, it's very easy. It's going to be 11. So now, what if we have 2 black dots? Okay, right? I could pick this one and this one. I could pick this one and this one. Like, it's like the previous thing I said. We have 11 letters, and you want to pick 2 letters, maybe A and D, right? So it will be combination of 11 and 2. But there's a problem. What if we're choosing randomly? What if these two randoms are adjacent like this? Well, we need to subtract this from what we have. So, but how many ways can we do this? Like this would be one group, like these two could be one, right? Then these two could be one, then these two could be one. Like, you get it? So if we count all of this, okay, imagine this one is the starting point, right? So we go all of them. For each dot, we'll have like a pair. So it will be 11. If you're not sure, just count. Okay. So things get ugly as we move forward. So now we pick 3 randomly from these 11. Okay. So again, like the 3 adjacent ones could be like this. All the 3 adjacent like this. How many groups of 3 like this we're going to have? Again, like the previous one, 11. So I'm going to go right minus 11. But still, there is a problem. Come on. Okay, minus 11. Okay, so now but there is a problem. What if we're choosing like 2 are close and this one is right over here? So this is again not acceptable. So we need to remove these. How to count these? So we're going to have 11 pairs like this, right? Okay. And if the next one is here or here, we have already count for it. So it could take for each pair like this, it could be in any of these circles, 1, 2, 3, 4, 5, 6, 7. It could be here, the other one, no, it could be like here. So for each pair, which we have 11, we have 7 other options. So it's going to be minus 11 times 7. Ooh. Okay. So now what if we have 4? Now I added 2 circles because it would be easier to explain the next. What do we have? 4 black dots. Okay. We're going to do it differently. Because if I write 11 or the one that are adjacent will be too many and too difficult to count. Okay, what we're going to do here is how many different ways can we put 4 black dots, right? So what if that would be one way? 1, 1, 1. Okay. So, or let me just take 2, 2, 2, and 2. Okay, this is the other one. And there is only another way. So there is no other way to put 4 around here. I'm going to go with 2 and a 3 and like this. Okay. However you want to put 4 black dots in the 11 parts, you're going to get a shape similar to this. Maybe you get 1, 4 white circles like this, white dots, right? Or you're going to get 2, 2, 2, and a 1. Or you will get a 3 and a 2 and a 1, 1. Okay, so this time I'm going to count like how many ways can we put this. Now here, so imagine you want to choose 4, okay, and the rest like this. How many ways can you do this? It's going to be 11. 1. See, I have to show it here. So it's going to be like this. Okay. Let me just put 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So randomly, you would pick any 4 that you want. Okay. That are adjacent. Okay. Then the rest will just come in place like this. They have no other way to go. Okay. And remember, how many ways can we pick 4 like this? 11. Because maybe I put this 4, or maybe I'll choose this 4, okay? Maybe I'll choose this 4. It's going to be 11. So this one is, okay, 11. I'm going to put right here. This one will be 11. Now this one, again, like, see, everything looks similar except this one, okay? So there's only one that is single. So the place that this one is, you can take it. It's just to have 11. You pick this one and the rest will come in place, okay? So again, in this shape, you could just do your own experiment. Will be again another 11 because the only one that is looks odd is this one. The looks, okay, they're similar. Now this one will be more because from the 11, you will pick 3, which is going to be like any of these have 11 ways. But look, now we have 1, 1, and a 2. 1 and 1 are similar, but these two are different. So these two could take this place, okay? Or maybe I could have not have the purple here, right? This is out, for example. I put this one over here. This could be the 2. Or the 2 could have been here instead of there. Okay, maybe 2 here, maybe 2 here, maybe 2 here. So 3 ways. So it will be 11 times 3. Ooh. So the total of this will be 55, but I'm going to write it as 11 times 5. Okay. So now, oh, they look all ugly. So let me see if I can undo some of these buttons because, oh, I need some fresh ones. Okay, so it will be 11 times 5. Now what if we have 5? Can we have more than 5? No, there's no way to put 6 here. Look, 2, 3, 4. For the 5 ones, I could only go here or here, right? If I take this place for 5, for the 6th one, I can't put it here or I can't put it here, no. So that's it. This is the last one. And you would see it now, it's very easy because look, the only one that it looks odd is this 2. So it will be how many ways can you pick 2 adjacent white bars, white dots? That would be it, right? For example, I have these to explain. So you randomly go choose, these are my 2 dots. Then the rest will come in place. See, this one will be here. This one has to be here. This one has to be here. And this one has to be here. And this one has to be here. Okay, so we're going to have 5. Okay, so it's just like how many ways can you put 2 white dots that are adjacent? It's going to be in 11. Whew. So we just have to make the sum of these. Let's do that. This is 11, 11, 5 times 11, so these 2. Okay, I'm going to change color now. So this will be 11 now divided 11 times 10 divided by 2 will be 55. So it's going to be 4 times 11. Okay, now this one. It will be 11 times 10 times 9 divided by 6. Right, this one will be like this. 11 times 10 times 9 divided by 6. So it will be 15 times 11, right? Yeah. So 15 times 11. This one is 15 times 11. Minus how many 11s? Minus 8 11s. So factorize 11s. We're going to get 7 times 11, which is 77. So this one will be 7 times 11. Now this one will be 5 times 11. Okay, we already have it. So let's count. 1, 11, 5, 11s. Like, let me write it like this. I don't want to make a mistake. So 1 plus 5 plus 7 plus 4 plus 1 times 11. Okay, so it will be 18, right? 5 and 5, yes. So the answer will be 18 times 11. Okay, which is going to be 180 plus 18, 190, 18 total. Okay. So again, for all of these questions I have no answer key. I think the approach is there, the way we need to do the questions, but I could make slips, I could make mistakes. So that's the end of this video. And remember, for any math lessons, physics lessons, you could book lessons with me. To do that, just go to About page of my channel. I have many different ways to contact me. Choose one, and I'll see you in class.